All right, welcome to the November 2020 OpenZFS leadership meeting. Thanks everyone for being here. We have just a few items on the agenda. Why don't we start with some updates from Brian on the OpenZFS 2.0 release schedule and then DRAID.
Sure. So we're pretty much all the way there. We've had 5 RC candidates now, and it's good that we had them. We had some good soak testing going on. We caught a couple of small issues, nothing too serious, but it looks like everything's come together pretty nicely. So I'm getting ready to tag the final release. So hopefully that will come out this month, hopefully early this month. But it's pretty much all set. So we just need to wrap it up.
Cool. Well, early this month might be, you may have to stretch the definition of early there, but it would be great to see that land this month.
Yeah, that's the plan.
Does that have the persistent L2ARC stuff in it?
It does.
Then the issue we were talking about earlier today, we might want to make sure the fix for that goes in so that you don't get panics if the pool gets suspended.
Yeah, I think that's still an open issue. If the pool gets suspended while you're rebuilding the L2ARC, yeah, I don't think that's handled at the moment, just exporting the pool. But I don't think we've seen that in any testing yet, but I think it probably is a real issue. Although if your pool gets suspended, maybe it's, you're already in a bad spot.
Yeah.
Brian, about release, I was gonna ask, do we have any list of things that are going in, or like we are not planning any more merges there at all unless it's absolutely critical, or what's planned for this point? For example, the one fix you merged today of mine, will it go in, or should I create PR, or it's not going in?
I think anything that's in the master branch currently, we might cherry pick at the last minute for the 2.0 release. There's some stuff there, little free BSD fixes, some documentation cleanup, that kind of stuff that we'd like to have, but super low risk, right? So I think that stuff can go in before the final release. Bigger changes, probably not. Although
I mean, but not about bigger ones, mostly about small ones.
Yeah, so if it's already in the master branch, I've tried to pick most things back that were small and were important. So that stuff I'll try to pull in again before a final release. Like I say, it's usually little. If you've got something in mind, definitely let me know and we'll talk about it and figure out if it makes sense or not. I think also we can totally talk about doing more frequent point releases after 2.0. So just to get in the habit of doing that, I think would be good. So we don't have a long gap necessarily between stuff. We can get fixes in if we need them.
Cool. Then should we just mention, I think there were a few PRs that are nearing completion or need some eyeballs, one being the DRAID.
Yeah. That one's pretty much just needs to be merged as well. Thank you, Matt, for your time reviewing that. That was really valuable. That got us pretty much over the finish line. So I expect that'll merge this week to the master branch. Me and Mark were just doing some last minute testing and, double checking and whatnot.
That's great. That's a huge amount of work to come to fruition after, I think, more than 5 years of work by, at least half a dozen people and several different companies.
Yeah, it's great to see that finally get wrapped up. So I'm pretty excited about that.
I think it's a great example of collaboration, across companies that we've facilitated with, the OpenZFS project.
Yeah, it was really nice to see people pick up that work and carry it forward, right? Even from different companies. So I think that'll be good.
Cool. Alan, did you want to mention the forced export PR?
Yeah, so we've got a version of forced export that works and actually passes the test now, which is nice. So yeah, we'd really like people to look at that. It works very well on FreeBSD and does actually work on Linux as well. And main use case, as I mentioned before, was if you have more than one pool and one of them goes away for one reason or another, then you want to be able to export, force export that one, even though it's not going to ever unsuspend, basically. So use cases of remote devices or something where you're have a local pool that you're using normally, and then a remote pool that you're, say, just using for ZFS send receive or something. And if your connection to the remote devices goes away, that pool gets suspended. But sometimes you want to be able to just force export that rather than trying to get it back, so you can resume it so that you can export it normally. Or I think the other case that Brian mentioned is, if you had a pool on a USB stick and you've disconnected the USB stick, sometimes you want to say, just throw the pool away and let my root pool continue to work instead of being stuck where, ZFS list doesn't work because the other pool is stuck holding the spawn namespace lock or whatever.
Cool.
So it has a bunch of tests and so on, but I would love to see some review and any other thoughts people have on that.
All right. And is that, are you expecting any more work on that, or is that ready to go as far as you know?
As far as I know, it's ready to go. It will depend what everybody else thinks of it, but in general, I think it's good to go.
Cool.
I'll definitely try to get you some feedback on that. No, that's one of the features we've seen requested the most over the years, so I'm pretty excited about it.
Yeah,
that's great.
I originally didn't know that I had much use for it until a couple of weeks ago when I ran into a case where I had a use for it, and it would have been really nice if I could have exported the pool and kept going instead of having to restart.
Cool. Well, speaking of highly requested features, I am back to working on RAID Z expansion. It's been kind of coming in fits and starts, but we have a renewed push to make some serious progress on that by the end of the year. So we're hoping to get like a final reviewable PR by the end of the year. Might not quite make that, but hopefully you'll be seeing a bunch of updates on that. So I'd love to for folks who are interested to help with testing that. We'll have a bunch of new features coming to that probably later this month, like writing with the new data to parity ratio after the expansion, performance improvements like after the expansion when you're reading and writing to the RAID Z. So we'd love to see more testing on that to help us shake out any bugs. Cool. And then anything else that people want to plug before we move on to the technical discussion about the non-interactive ZIOs? Any other reviews that folks want to draw attention to? All right. Then Alexander, let's chat about the non-interactive ZIOs.
Yes, thanks. Last several weeks, I was trying to investigate how to prioritize what I call interactive I/O, which at this point both sync and async, comparing to scrap, initialize, receiver, whatever we're doing in background, because timeline of the first are seconds and milliseconds, and second and part is minutes, hours, forever. And I tried several sites. I experimented with SCSI and ATA priorities. Unfortunately, I haven't found anything usable there. SCSI priority seems like not supported. ATA priorities not doing what I want from them. They would do orient more on high priority, not on low priority. And marking everything high priority just kills IOPS, practically handling all requests in order of arrival, which is not fast, obviously. So I went higher to ZFS, and for several days there is already a hanging PR, which throttling non-interactive requests if there are any interactive requests are active or they are not completing within several last completed requests. So practically, if what I am fighting with is that if some hard drive see a large sequence of sequential requests, it quite often give up on random ones and handling them sometimes 1 in 4 seconds, which is obviously death for any interactive workload. And with my patch, I see dramatic improvement of worst case latency from 4 seconds to 1/8 or at least 1/4 second. So like 16 times lower latency, I think it's great. And one question I have left, that part with Scrap, it works as good as it can be, I believe. I don't have any question to that part. But I now looking on higher part, differentiation sync versus async requests. And it's not so straightforward science, obviously. Async requests are not so high priority, but they must be done within reasonable time, within seconds. We cannot give up on them for a long time. And one more complication is that for write, if drive has write cache and we already pushed there tons of data, I'm not sure drive will react on us fast anyway, no matter what we do. And so my question was about motivation of the code we have now, in particular async write. What was it really seen benefits of increasing write queue depth following the dirty data amount in Arc? Because if we have write cache enabled, then I'm not sure there's any difference whether we have a queue depth of 1 or queue depth of 10, minimum and maximum. From throughput performance, it just pollutes drive queue. I suspect.
Yeah. So at a high level, I think to me, it does make sense to address these like truly background activities separately from reads and writes, even the async reads and writes. So like, which is what you've done, which seems okay to me. I was just a little confused by the terminology, which I think we can clear up. For the async writes and like increasing the queue depth, yeah, we did see that it does matter, and it helps a lot when you have workloads that are where like you have a lot of reads going on. And I'm pretty sure that we did test this with just plain hard disks. Ultimately, like, I think that even with a write cache, like there's only so much stuff that you can throw into the write cache, and essentially what we're doing is like, I think that the default before we made that change, it was like the write queue depth was 10 and the read queue depth was 10. And so what you would typically see is like, for hard disk, especially 10 is like a lot, right? Because it can only actually do one thing at a time. So if you have like if you have some sync reads, and then but not like, you don't necessarily have a very high queue depth of sync reads. Like you have a couple threads that are coming and hitting with reads. So maybe the sync read queue depth is typically 1 or 2. If you always have like 10 writes outstanding to the drive, then only sending it one read at a time, like even if it's processing them in random order, like 90% of the time the drive is going to be doing the writes, and 10% of the time it's going to be doing the reads. So what you would see is like, while you're syncing, like if the write workload is not totally hammering the disk, then essentially like while you're syncing, you hammer the disk, and then while you're not syncing, you're not doing any writes. So the point of that scaling up is to smooth out the write workload, so that when the write workload is not like at the extreme, then we are only sending out a few writes to the disk at a time, so that the latency of synchronous reads remains okay.
The problem with that queue depth, if you have write cache, you put more. If cache is empty, you put data quickly there, latency of write very low, and you barely ever reach 10 requests of depth. They complete faster. On the other side, but when you get cache full, you have immediately 10 requests waiting, and you get all the latency of 10 requests of 1 megabyte each, thanks to aggregation, and the good if they're not random.
Yeah, that may be. I haven't looked at that in detail, like how it behaves with the write cache on that kind of micro scale. So I guess what you're saying is that if you have the write cache enabled, then when the read comes in, the write cache is already full. It's already like busy processing the write, doing write back for the write cache, and so the read is already going to have a high latency, regardless of whether we have a bunch of writes outstanding at the same time or not.
No, yeah, the additional writes outstanding don't give us more bandwidth because all cache is already full, but they increase latency and pollute queue, reduce queue depth for other traffic. Because for SATA we have only 32 tags, and if we have on FreeBSD max fees not increased to 1 meg, each 1 megabyte request means 8 tags because of splitting into 128K chunks. So we may end up with this completely stuffed with write queue and no single read there, and just wait while write complete.
Yeah. So are you saying that therefore having the scaling down is good because it will help to mitigate that, or are you saying like scaling down isn't really going to help that much because of the write cache?
No, I just don't see point to scale up so high. That's why
okay.
Staying low is the least of bad things we could do, at least with write cache enabled. With write cache disabled, I can't believe that we may benefit from pushing more there, since there will be latency drive.
All right. So your question is, why is the limit 10 and not like 3 or whatever?
Yeah.
Okay.
One of.
Yeah. So it's been 10 for 20 years. So I don't think that we changed that. But yeah, that's definitely a good question. And for hard disks, yeah, like there's really no reason for it to be so high for any of the queues to send, more than like 1 or 2 at a time. And I think that the issue is that for other types of hardware storage devices, like they can do more at once, like SSDs, right? And at least like at the time that we were doing this, which is maybe 5 years ago, there still was not a good way to detect like what does that curve of like queue depth to throughput actually look like? Where like for hard disks, it's basically like flat, right? Like you get to queue depth 1, the throughput doesn't really increase as you increase the queue depth. But for SSDs, it's like, closer to being linear for at least a little while. And for other things, like like arrays that are underneath ZFS, then it's like even weirder. But yeah, I would agree that like if we had a way to know for sure that having a higher queue depth doesn't help, then to limit that, then that would be a good idea.
Well, I think it significantly depends whether cache enabled or disabled. So another question related I have to this topic is what people are typically using, because in many sources I see mentioned that Linux may disable by default, that Solaris or Illumis in some cases may disable by default. FreeBSD doesn't. So like what's our target market?
Solaris or Illumos did pre-ZFS did disable it by default. And then with ZFS, when you give it the whole disk, it would enable it by default, and then rely on the cache flushing commands.
That's what I heard. What's about Linux? Because I don't know so much in that area what people are using. I know there are mechanisms to control it, but what's the default?
I was going to say Linux behaves pretty much the same way. It'll enable it by default if you give it the whole device, and if you don't, you just give it a partition, then it doesn't touch it.
No, but if the drive have it enabled by default, it won't touch it. It will remain enabled.
Yes, yes.
It doesn't
It'll
force.
leave it as whatever the system set it to.
Yeah. So it sounds like you would typically have the write cache enabled on Linux as well,
Yes.
because you would typically be giving it the whole disk anyways.
Yeah, it's probably pretty unlikely that it'd be disabled.
Yeah.
Oh, okay. It's just Brian. I looked through history. I see on ZFS on Linux, OpenZFS now we have minimum async depth of 2. You increased it several years ago when somebody complained that on his disk with write cache disabled, there was low retrieval performance, and there was kind of consensus that 2 is somewhere in the middle.
I don't remember the exact patch, but it's definitely possible. I'd have to go back and dig it up. What was it before? Was it 1? We increased it to 2, or we?
Yeah, it's still 1 in Illumos and was 1 in FreeBSD, but in ZOL it was increased to 2.
Yeah, we'd have to go back and look at the issue linked from the pull request. There's probably a history there about why.
No, it makes sense when write cache is disabled, because without queue depth at least of 2, you just cannot write sequentially without waiting full rotation every time. It's just physics.
Well, like Matt was saying, we do have a pretty good way to detect that these days. Not only if write cache is enabled or disabled, but if it's an SSD or a hard drive. So I think it makes sense to, revisit all these things and maybe have different tunings based on what's there. But it's going to take work to figure out what makes sense, right?
Yeah, there's some code, I think, in the mirror code that changes based on whether it's a rotating disk or not. And
yeah, there are several places in code that would also do aggregation differently for hard disk and SSDs and something else. I think there were maybe 2, 3, or 4 places through ZFS.
Yeah, I think that's plumbed all through the VDEVs now, right? So it's pretty easy to check. So it wouldn't be hard to do something like that if we knew the right values to set.
Yeah, I've always wanted to do something where we could detect this dynamically, because you never know what how the hardware is going to lie to you. And even if we knew like HDD versus SSD, it's hard to know, like, okay, so what's the right value for SSDs, or so it would be really sweet if we had something that would, like actually do at least reads, or maybe we reserve some regions where it can do writes. When you open the pool or when you create the pool the first time, it would like measure the performance of like queue depth 1, 2, 3, 4, 5, and see like at what point do we kind of reach the plateau of throughput, and then kind of set the max queue depth based on that.
Yeah, it reminds me a bit of some of the work Netflix did in the FreeBSD storage layer for their SSDs, where they would throttle writes to a point where do as many writes as you can until it starts to impact the read latency, and then throttle the writes, kind of thing.
Like they have a very heavily differentiated read versus write workload.
Yeah,
that's why they have quality of service for read, but they can do writes as fast as it allows. I'm not sure anybody else has the same characteristics, but yeah. No, in code of Scrub, I was thinking about latencies, but I ended up with different approach. Like if we send 5 Scrub requests and during that received none of interactive responses, then obviously they are starving, and we must stop. Yeah, we must stop Scrub and let those complete and then continue. Maybe something like that could be done for write times. I don't know, or it would be too aggressive.
Yeah,
because
I'm
for
not
Scrub,
sure.
obviously, there's nothing too much. We can let it go as long as we want, as long as it doesn't interfere with workload. But
yeah, I mean, there is the way that it used to be. I think this is maybe pre pseudo sequential Scrub. It was very aggressive about having the Scrub back off. Like whenever there was any other IO, then basically the Scrubs would pause for like 1/10 of a second or something.
Yeah, I looked on that code, and we actually had it that those delays internally even after sequential scrub was implemented.
Okay.
But I found that it just cannot work reasonably because it delays
Yeah.
how IOs are put into the queue, not how they're
Yeah.
handled. And there is delay like 5 megabytes, and 5 megabytes of random IO, that's a lot of delay. So
Yeah.
it's to make it
So
really reduce delay, it has to be very slow.
Yeah, and that mechanism would cause the scrub to go very, very slow,
Yeah.
unreasonably slow. So
That's why I decided not to move it forward, but implemented what I've done.
yeah,
But question,
I like the idea of what you've done. I need to look more deeply at kind of the exact algorithm, but I like the idea of like essentially if we detect that we are starving out other queues by like we've issued 5 scrubs and no other things have completed, then let's kind of hold back on issuing ours until somebody else completes. That's a cool idea.
So now I'm thinking maybe same could be done for writes. Maybe we may play with coefficients lower and higher. For scrap, I did 1 in a 5. We can do it even less aggressive, 1 in 10, just to handle worst possible cases. Just question what to do in that case. If we were doing write at Q depths of 10, should we drop to the floor, to none, or to 2, or like?
Yeah,
it's a very big jump, because for scrap, it never sends more than 1 request while there is something interactive. But for writes, wouldn't it be too aggressive to send just 1 if there are anything really interactive? Would it be too strict?
Yeah, I don't know. I mean, even I think even the behavior. So the behavior that you've implemented, as long as there are some other IOs completing, then is the behavior the same as it used to be?
No, it still keeps Q depths of 1. So it goes to full Q depths of 3 only when there is nothing really else. So it can breathe freely.
So
but
even if basically like even if other IOs are completing, so I'm thinking about the non-HDD case, like you have an SSD or something, and we're completing lots of all kinds of IOs, and the disk can actually do like lots of things at once. Then are we effectively reducing the queue depth of scrubs from 3 to 1?
Yeah. No, I experimented with some SSD, and I saw even high-end SAS SSD, not NVMe, but still pretty fast. And I still saw latency difference between Q depths 1 and even 2, especially and even 3. So there is nothing free. The latency grows. Maybe, of course, not as dramatic as with hard disks, but latency is growing. So
yeah, so you're saying like when you varied the scrub queue depth from 1, 2 to 1, 2, or 3, and then the latency of synchronous reads increases as you have more of these kind of competing scrubs. Is that right?
Yeah. I saw the like maybe between 2 or 4 times variation. Not dramatic, not 1,000 times as I saw with real starvation with hard disks, but still, like question, how much do we want to affect workloads? The lower the better.
Yeah.
But it's tunable. Like somebody doing SSD only could always increase minimum. I haven't hard coded value of 1. Minimum could be increased to 2, and it will follow.
I mean, to me, all this stuff makes sense to have these options, and changing the default behavior of to say like when we've detected that we're starving somebody else, then let's back off. That makes sense for all hardware storage types. Essentially changing the default queue depth when there's when there's other IOs going on seems like something that we could kind of discuss orthogonally and evaluate the impact on SSDs and whatnot.
So you propose just add checks for starvation with some loyal
I mean, to
parameters.
me, the starvation fix seems like a more clear win in all scenarios.
Mhm.
And I guess I would, the change of the queue depth, scrub queue depth, I guess I would just like to see more data of other, like how does it really impact scrub performance and read latency on different types of hardware to justify a change in the default, if that makes sense.
You're talking about scrap right now, not about asyncs.
Yeah, yeah.
No, because part of that is hard-coded in the code that dropped to minimum. Because previously minimum value was literally not used ever. ZFS always
Yeah,
use
yeah.
maximum.
Yep.
So if somebody wants to mod set, he can set minimum value higher and restore previous behavior, kind of. So for async write, we do use range, but again, it's tunable. Okay, thank you.
Okay.
Discussion.
Anyone else have thoughts on that?
Yeah, this is Richard. We did a bunch of work on this a while back, and it gets really difficult because writes are, you're writing to a volatile write back cache, and it's damn near impossible to ever predict the impact of writes versus latency versus queue depth. So it's extraordinarily difficult. But there are some other techniques we can do, and it's maybe a good chance for conversation at the bar someday about other things we can do in that whole ZIO pipeline to improve our estimation of the performance of the drives.
Okay. I think this is the last item that we had on the agenda. So any other thoughts on this or other topics folks want to cover? All right. In that case, our next meeting is going to be in 4 weeks on December 8th. And it will be, I think, at the same time as today, because the last one was in the morning. Yes. So the next meeting will be 4 weeks from today, December 8th, same time as today. And enjoy your extra 20 minutes back from this meeting. Bye, everyone.
Thank you.
Thanks.
Bye.
See you.